Hi, and welcome to a new week. Today, we are going to start the next module called semantics. And when we were talking about syntax, I had said that syntax and semantics are quite interconnected with each other, but semantics is a little bit more formal than what we were doing in syntax, partly because semantics has to do with logic. And so if you've taken a philosophy class, if you've taken math classes, you probably would be familiar with most of the things that I'm going to be talking to you about this week. So you have new readings for this week. It's chapter 7 of your textbook. Read pages 202 to 232. And I have a word of caution over here because the textbook deals with the field of semantics called as lexical semantics. So you might have heard of lexical semantics before. It has to do with each individual word meaning. So when you say the word dog, what exactly do you mean by that, right? That's lexical semantics. But the lecture slides that I'm going to be using and the video is going to be talking about a lot more recent developments in the field of semantics, and the way that I teach it is closely related to mathematics and philosophy rather than lexical semantics. So just pay attention to that, especially when you prepare for your final exam, that you have to do your readings, but do pay attention to what we're doing in the lecture slide, in the videos as well. So just as a reminder, we have finally reached the syntax or the sentence level for language, and that's what we looked at last week with respect to the phrase structure rules. And then today what we are going to be doing is we are going to look at how do you actually get meaning from the bigger sentence structures that you created in syntax. So semantics is a study of meaning in natural language. And so the easiest way to start talking about semantics is to ask you to name this image that you see on your screen right now. So if you can think of the way that you would refer to this product, think of that for a minute. And very often the kind of answers that I get from students are Coke. Some people might even say like Pepsi or iced tea. Some of you may say Long Island iced tea, right? Or your favorite version of whatever alcohol looks like that color. So you can think of different names for this product. Some of you may say pop, some of you may say soda. Now, the idea is that even though there are multiple ways of referring to this product, you know the meaning behind all these words, right? There is a meaning that's connected to each form of this product. And when you get into that level, what do you actually mean by meaning? If I tell you blue-haired dogs are sleeping right next to the mantelpiece, you know the meaning of the sentence even though you've never heard of the sentence before or you've never seen blue-haired dogs before, right? Yes, you know the meaning. And so the question is, how do you map from what you know about the syntax, right? And so I've broken it down into the syntax for you. The whole thing is a sentence. And then you have a noun phrase, which is your subject, and your predicate, which is your VP. And within your VP, you also have a prepositional phrase next to the mantelpiece. How do you actually individually get the meaning from each of these phrases, but then when you put it together, you get the entire meaning of the sentence? That's the whole point of semantics. Now, the uncontroversial idea when we start talking about meaning is that language is a system of thought, right? When you think, you always think in language. It's very difficult to kind of isolate your thoughts away from language. But the question is, how exactly does language actually encode thought, right? And so you can think of a simple system of language, but I'm going to tell you that this is actually not true, where you have an image that is represented by a form. So there is an inherent connection between the form and meaning. But this has to be memorized, right? Because how do you know that this is actually what the bell looks like? Or how do you know that a snowman looks exactly like that? And that's a stipulation. It's arbitrary. It's memorization. Language is not a system like this. We've been exploring this throughout the different modules that we've been looking at in linguistics. Language is not a system like this precisely because you can think of new meanings and you can think of new symbols, right? We have emojis that are new and are added every single day to your phone dictionary, for example. And so your mind and your thought processes are infinite. You can come up with new forms, you can come up with new words, etc. So therefore, it's not a very simple system like the one that we just described in the previous slide. The way that I'm going to introduce meaning to you is by giving you a sentence from a language that you've never heard before. This is Startimstedt. It's indigenous language spoken in Canada, in northern parts of Canada, and British Columbia. And if I ask you what is the meaning of this word, what do you actually need to know in order to know the meaning of this word, of the sentence, right? Well, one, you need to know the meaning of the words, right? I mean, obviously, I haven't told you the meaning of these individual words, so you wouldn't know the meaning of the sentence. But apart from the meaning of the individual words, you also need to know the structure, which is your syntax, right? And then you also need your most crucial element, which is very often overlooked when you look at first language acquisition. But when you learn a new language, when you learn a second language, it's very often explicitly mentioned in second language instruction. And this is a set of rules for deriving the meaning of the sentence, right? So when you talk about semantics, you need to know how do you derive meaning and what are the rules for deriving this meaning. To do that, what we do is we are going to explore some fundamental notions, some fundamental rules and concepts in natural language semantics. So we can call a language L, right, capital L, and we can say that there are two things to any language L. A language L needs to have a finite number of units, right? So these are parts of speech, idioms, words, etc. And then it also has a finite number of rules, right? And the rules can derive both the meaning as well as the form, or both the syntax and the semantics of all these primitive meaningful units. So when we talk about combining different phrases together, combining different structure together to get the meaning, we often talk about the principle of compositionality, right? And compositionality is the mode of combination of these different kinds of expression. So here are some pieces of evidence for you. If I say the dog bit the man versus the dog bit the cat, you know that these are two different sentences, or the sentences actually mean two different things, because in the first case, the subject remains the same between the two sentences, but in the first sentence, you have the object as the man, and the second sentence, you have the object as the cat. And therefore, you know that the object of the biting is different, and therefore the meaning is different. Now, you can also change the syntactic structure, and that also leads to meaning change. So you can say the dog bit the man versus the man bit the dog, and therefore you again get a change in meaning. So the overarching question is, how do you combine the subject, the verb, the object together in a compositional way, right? Like what combines what? First. So you can either stipulate that the subject combines with the verb and that unit combines then with the object, or you can say the verb first combines with the object and then that unit combines with the subject. So how do you know that? That's the principle of compositionality that we are going to look at. When we talk about semantics, we often talk about infinite creativity with semantics because that's something that you can do, right? We saw this with the stacking of adjectives in your syntax lecture. It's very similar to that. You can say the cat is sleeping, and then you can add things to this and create more sentences with different meanings. You can say the cat behind the barn is sleeping, the cat behind the dog behind the barn is sleeping, and so on and so forth. So with syntactic and semantic competency, you can create multiple loops and you can embed things and create bigger structure. That's the idea behind infinite creativity. So here is an example of how you can convey meaning. Here's a dialogue between two people. Person one says, "How did Dave's physical go?" And person two says, "Well, he stopped smoking." And so from this conversation, you can infer that, well, Dave was a smoker. Not anymore because he stopped smoking, but it used to be the case. In the past, there was a time when Dave used to be a smoker. And this is not something that person two has explicitly told you, but you are implicitly deriving from what person two has told you, that Dave was a smoker. There are more things that semantics does for us, and here's an example for you. Every man loves one woman is semantically ambiguous between two meanings. So we've been talking about morphological ambiguity, syntactic ambiguity, and now we are going to talk about what semantic ambiguity is. And so I want you to think about the two meanings for every man loves one woman. One of the meaning is that for each man in the set, right, there is one woman that he loves. So suppose there are three men that we are talking about when we say every man: John, Dave, and Thomas. Now, John loves one woman, say Mary. Dave loves one woman, say Jane. And Thomas loves one woman, say Diana, right? Each person loves a different woman. But the second reading is that there is one woman and all the men, right? John, Dave, and Thomas loves that one particular person, right? Say Helen of Troy, right? Or something like that. So those are the two meanings. The ambiguity lies in the semantics of every, and we've been treating every as a determiner from syntax. So things like many, every, some, everyone, etc. are determiners, and that's really where that semantic ambiguity is coming from. And I want you to compare every man loves one woman with the sentence John loves one woman, which is clearly not ambiguous because there isn't a determiner like every in the subject position, and therefore you get only one reading, that there is one person John, there's one woman, say Mary, John loves that person, right? John loves Mary. In the remainder of this video, what I'm going to be doing is I'm going to establish some meaning relations. We also call these as logical relations between sentences and truth relations between sentences. And this is what we are going to be doing informally in the rest of this video. And we are going to be formalizing this with tools from formal logic in the next video. One of the first semantic notions that I'm going to introduce to you is the semantic notion of equivalence. So there are some sentences that mean exactly the same thing, but structurally they could be very different. So John is blonde and Mary is a brunette is the same as saying Mary is a brunette and John is blonde, right? The reason is both A and B convey the same meaning and the same truth. And therefore, this relationship between sentences A and B is called as equivalence because A is a faithful paraphrase of B and vice versa. So here are the semantic conditions of equivalence. Whenever you utter A, whenever you utter the sentence A, and the truth of A is the same as whenever you utter the sentence B, right? So therefore, we can say that in semantics, we often talk about truth conditions. So whether a sentence is true or false is something that we care about quite a bit in semantics. So if sentence A is true, you can say the sentence B is also going to be true. If sentence A is false, sentence B is also going to be false. And just a note over here that we are not really talking about whether you know if the sentence is actually true, right? We are not evaluating whether the sentence is true based on your world knowledge. We're talking about truth conditions, right? So we know the conditions that are required for this particular sentence to be true, and that's all we care about, all right? We're not really worried about whether John actually loves Mary in the real world. That's not our worry for semantics, or this version of semantics that we're talking about in this video. So here's an informal definition of semantic equivalence. Let's take any sentences A and B. They are semantically equivalent if they are true and false in the same situation. So if there are situations 1, 2, 3, and 4, and in situations 1, if sentence A is true, then sentence B is also going to be true in situation 1, right? That's the way that you understand semantic equivalence. The second semantic notion that I'm going to introduce to you is called as entailment. And entailment, to see entailment, I want you to look at sentences A and B. A is Mary danced and John sang, and B is Mary danced. Now, you know that B is actually a shorter version of sentence A. And when you look at the truth values or the truth conditions of sentences A and B, you know that when A is true, B is always going to be true, right? Because if Mary danced and John sang, then it is always true that Mary danced. That's the semantic notion of entailment, that whatever is entailed in B is already contained in A. Now, unlike equivalence, entailment doesn't work vice versa, right? So if you have two sentences A and B, A is Mary danced and John sang, and B is Mary danced, it doesn't it doesn't mean that B entails A. It only means that A entails B, right? Because Mary danced is the shorter form of Mary danced and John sang, right? So here is entailment. A sentence A entails a sentence B if the truth value of A guarantees the truth of B. So if sentence A is true, it necessarily means that B is also going to be true. Whenever A is true, then B is true, right? That's entailment. The third semantic notion is called a contradiction. This is a little easier than entailment and equivalence because everybody knows what a contradiction is. If I tell you that 2 is a prime number and 2 is divisible by a number other than 1 or itself, that is a contradiction because a prime number, because you know what a prime number is, and your definition of a prime number does not allow you to have that number divisible by a number other than 1 or by itself, right? So that's a contradiction. John sold a car to Mary and Mary didn't buy a car from John is a contradiction, because if Mary bought a car, then you cannot negate it and say that Mary didn't buy a car from John. So here are some informal definitions for contradiction. Two sentences A and B are contradictory if there are no situations such that both are true descriptions of it. So whenever sentence A is true, sentence B is always false, right? So if John bought a car from Mary, John didn't buy a car from Mary is always false in this situation, and therefore it's a contradiction. So a contradiction, you always get opposite truth values. If A is true, B is always false. If A is false, B is always true. Now, we have seen informal definitions of what each of these concepts are, but now what I'm going to introduce is what exactly are we talking about when we talk about equivalence, entailment, and contradiction. So let's look at some other sentences for each of these concepts. So I want you to look at the sentences on this lecture slide. Bill doesn't swim or Sue doesn't dance is equivalent to, it is not the case that Bill swims and Sue dances. I want you to look at the words or the particles that I've bolded. So I have bolded the negation, the contraction of the negation, int or not. And then I've also bolded or and and. And remember that these are things that I haven't talked to you about in syntax, and I said I will come back to this in semantics, because these are things that we call as conjunctions, right, or negation. They conjoin two things together. So things like Bill swims and Sue dances, or Bill doesn't swim or Sue doesn't dance. You're conjoining two sentences together, right? In syntax, we saw a sentence embedded within one sentence, but we didn't do trees for one sentence and another sentence conjoined together. But that's what we're going to look at in semantics. So when I say Bill doesn't swim or Sue doesn't dance, it's equivalent to it is not the case that Bill swims and Sue dances. So we can refine the definition that we gave to equivalence and say, we can use operators such as negation or the conjunction operator or the disjunction operator and say not A or not B is equivalent to not and bracket A and B. The difference between the first one and the second one is that not A is a more local kind of relationship. The negation is negating just the sentence A, and negation B is negating just the sentence B, but not A and B is negating the entire A and B conjunction. With entailment, if you want to look at Mary danced and John sang and Mary danced from before, you can say that for any two sentences A and B entails A, right? Or A and B, the truth of A and B entails the truth of A. And so here are some more examples. Mary arrived and John left entails Mary arrived. It rained and it will rain again entails it will rain again. Sarah cried and Tom laughed entails Sarah cried, right? So you can say that A and B entails A. For any arbitrary sentences, A and B, if you combine them together with the conjunction and, A and B entails the truth value of the sentence A. For contradiction, these are all examples of contradiction. Mary arrived contradicts Mary did not arrive. It rained contradicts it did not rain. Sarah cried contradicts Sarah did not cry. And it was dark contradicts it was not dark. And therefore, for any arbitrarily chosen pair of sentences A and B, A contradicts the negation of A, right? Or A contradicts not A. And therefore, you can combine these two together and say A and not A is a contradiction. The last concept that I'm going to be introducing in this video is something that we saw very early on in this lecture. It's semantic ambiguity. And I'm going to introduce a little bit more complexity with semantic ambiguity than what we saw earlier. Take a look at the sentence, Mary arrived and John left, or Susan called. Now, here again, there are two readings. It depends on how you do the bracketing for this sentence. Now, you can bracket Mary arrived and John left in one parenthesis and then put Susan called in a different parenthesis. Or you can put John left or Susan called in one parenthesis and put Mary arrived in another parenthesis. These two bracketings would give you two different readings. The first reading is that either Mary arrived and John left, comma, or Susan called, right? With the first bracketing that I told you. And the second reading is Mary arrived and either John left or Susan called. So for any three sentences, A, B, and C, you can say that without the bracketing, A and B or C is ambiguous, right? Because I haven't told you what the meaning of this is, and it can be interpreted either which ways. So here are your semantic intuition summing up. We have talked about entailment, we have talked about contradiction, we have talked about semantic ambiguity, and we have talked about equivalence, right? So 4 semantic intuitions, which I have kind of formalized for you, but I'm going to be formalizing this a lot more and introducing set theory and truth tables in your next lecture. But this is kind of summing it up. A and B entails A contradicts the negation of A and B or C is ambiguous, not A or not B is equivalent to not A and B. And so just a note over here that if you are a secondary ed math major, topics in semantics and next video might be a lot easier for you because you probably have already done truth tables and you know what I'm going to be talking about. But if you've never taken logic, if you've never taken any class with truth tables in it, it might be a little wrapping your head around, but do feel free to come to my office hours or send me an email if things are unclear after you listen to the next video as well.